In this problem, we are asked to determine the tension in cable AC, which is right here, knowing that the resultant of these three forces, so this tension force, this force F1, and this force F2, must be directed along line BC. So it must be directed along this line. And we also want to figure out the corresponding magnitude of the resultant. So what is the magnitude of my resultant R? Now, the first thing I want to do is I want to redraw this just a little bit cleaner and figure out all my geometric considerations. So what angles that AC and BC are going to make with my X and Y axis. So I'm going to draw my point C, and I'm going to draw my easy lines first. So this 50-pound force goes straight down, and my 75-pound force goes like this. And we know the angle between these two forces is 25 degrees. Okay. My cable, which is AC, it's a tension. And we always know a tension is going to point away from the point we're looking at. So that's how tension works. Because it's a rope, even if it didn't say tension, if we want a force in it, we're going to point it away from, in this case, point C. So we're going to call this T. Now, what angle does T make with my X or Y axis? So I know that the angle under here is 65 degrees. And what I can do is that I can extend this vertical line right here. So now I have two vertical lines. I have a vertical line right here, and I have a vertical line right here. This, from geometry, what do we know? We know if we have two parallel lines and we have an intersecting line, then the alternate interior angles are equal. So we know that 65 degrees is going to be this angle right here. So this is going to be 65 degrees. Now let's draw in my resultant. I had neglected to do this, but my resultant is going to be along this line BC. I'm going to just call it R, and we need to do the same thing. We need to figure out its angle. Well, luckily, it's the same exact idea. We have a parallel line from A to B. We have this parallel line. Well, here it's drawn in with this 50-pound force, but this alternate interior angle is going to be equal. So we know that this needs to be equal to 35 degrees. Okay, so now all we have to do is we have to break up all of our forces into X and Y components and combine like terms. The one thing that I need to define is my positive direction. So anything to the right is going to be my positive X. Anything that's going up is going to be my positive Y. And I'm just going to work through all these forces, break them into X and Y components, and deal with adding them in a later step. So first, let's start with T, my tension. So my I component, you just need to be careful because for whatever reason, students always want to say that X goes with cosine, but it doesn't. It goes with whatever component of the triangle is going to be in this horizontal direction. In this case, if you use SOHCAHTOA, you'll see that, okay, this is going to be the sine. We know tension, and to get this horizontal component, we need to use the sine. So T times the sine of 65. And we need to make sure we realize that this sine is, when we break this up into components, is going to be pointing towards the left. So it needs to be minus T times the sine of 65, I, and then we'll have plus T times the cosine of 65J. And let's get what the sine and the cosine is right now. So the sine of 65, the cosine of 65, this is going to be equal to 0.91 T, and this is going to I, and plus, oops, don't forget the negative sign, that would be bad. And then we'll have 0.42 T t in the j direction. Okay, let's work on our next force. So this will be the resultant. This will be r. So with r, well, when we break this up, we're going to have, again, a minus x, but we're also going to have a minus y. So we need negative signs in the x and the y direction. It's going to be the same thing if we look at what angle we're looking at. So with the 35-degree angle, sine is going to be in the x direction, and cosine is going to be in the y direction. If you really hate that, you could figure out what this angle is right here. It's going to be 90 minus 35, and then the cosine would be that angle. So what, 55? So you'd have the cosine of 55 is the same as the sine of 35. But I'm going to just keep doing it this way. So we'll have minus r times the sine of 35i minus r times the cosine of 35j. So let's figure out what the sine and the cosine of this are. Sine of 35, cosine of 35. So this is minus 0.57 r in the I component minus 0.82 r in the j component. All right, now the 50-pound force is easy. It's only in the y direction. So this force, I think I called it F2, is just going to be minus 50j. And my force F1, well, we just do the exact same thing. So it's going to be equal to, well, when we look at this, it's going to be positive x. It's going to be minus y. So we'll have 75. Again, the sine goes with the x. So sine of 25i minus 75 times the cosine of 25j. And let's do that. Let's calculate this. So we'll have that this is equal to, and I think I'm out of room, so this is equal to 31.7 I minus 68 J. Okay, so now we've broken all of our forces into components. Let's just make sure our signs are right. So T is a minus and a plus, minus I plus J. R is minus I minus J. F2 is minus J. And F1 is plus I minus J. So everything looks good so far. What we're going to do is we're going to use this equation right here. In general form, my resultant is going to be equal to F1 plus F2 plus, in this case, T. And this is vector form, so this would really be R x of I plus r y of j is equal to f1x plus f2x plus tx in the I direction plus f1y plus f2y plus ty in the j direction. So all this means is we're going to have two equations. We're going to have an equation with my I component, and we're going to have an equation with my j components where we combine these like components. And I'm just going to do that in one step now. So what we'd have is Rx is equal to f1x plus f2x plus tx, and the same equation for ry. So when we do that, we're just going to take all our I terms. So we'll do x first. So we'll have minus 0.57r is equal to minus 0.91t. F2 doesn't have anything. And then we'll have plus 31.7, just a number. So 31.7. Now my y, let's do my y, is going to be equal to this minus 0.82. I need to move this up. I'm going to run out of room. So this is going to be equal to 0.82. That's here. Equals 0.42t minus 50 and minus 68. And this is really going to be the last step that I am going to color code because now everything's going to start to combine. So let's just combine this minus 50 and minus 68 right now. So we'll get minus 0.82, and I did forget my r. So 0.82 r is equal to 0.42t minus, what's this, 118. Okay, so now I have two equations and I have two unknowns. I have my r and my t. So what I can do is solve one of my equations for r, solve one of my equations for t, or t, and plug it into the other. In this case, I'm going to solve for r, so I can solve for t, or part A, first. So we're going to get, let's just solve this for r. So r is going to be equal to minus minus 0.91 divided by minus 0.57. 1.5, or we'll call it 1.6 t. And then we'll have this 31.7 divided by minus 0.57. And this is equal to minus 55.6. Okay, so now we can put this into this equation right here. I'm actually going to divide out, I'm a little space constrained, so I'm going to divide out the minus 0.82 first. So I'll have 0.42 divided by minus 0.82. So we'll have r is equal to minus 0.51t. And then we'll have this minus 118 divided by minus 0.82. We'll get plus 143.9. Oops. Held that too long. Okay, so now we just need to put this expression we have for r into this expression. So we'll get 1.6t minus 55.6 is equal to minus 0.51t plus 143.9. I think I just fit it on the screen. Now we combine like terms and we combined our constants. So we'll get here, this is equal to 2.1t is equal to 55.6 plus 143.9 is equal to 199.5. So t is going to be equal to 2.1. So 95 pounds. So this is part A. Now, part B, very simple. Once we have part A, we have an expression for what my resultant force is. So I can just plug it into that equation. So I'll get that R is equal to 1.6 times this 95 minus 55.6. And that will give me my answer. R is equal to 96.4 pounds. So there you have it. Hopefully this video has helped you be able to figure out unknown forces when you have a resultant that's constrained along a certain direction, and just be very mindful of your signs. Even making this video, I've had to do a few takes where I lost a negative sign, just wasn't paying attention. So be very mindful of the signs of your different components, or you will just get a wrong answer.